Okay, Foundations of Algebra, week 5. We're ramping up here. We're going to do scientific notation and some more equations and inequalities, a lot of stuff. So let's start off with scientific notation. Okay, so what is scientific notation? It is a number with a ones place. So like, for example, 9 and the tens place could have other decimals too, but how about a 9.3? And then it's always going to be multiplied by 10 because we know that multiplying by 10 moves a decimal or adds zeros to a number. And then maybe let's say to the 20th, right? So why would we want to write that? We'd want to write that because 9.3 times 10 to the 20th in standard form would be 9, 3, and then 19 zeros. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we don't want to write that and then have to do arithmetic and then write it again and all of that. So if we use scientific notation, we can write really big numbers in a short way and do math with them. So we can add, subtract, multiply, and divide. And guess what? They just use the rules of exponents. So you can do it, but let's go through it. Okay, so here we write this table down, and we want to know how many more pieces of mail were handled by the U.S. Postal Service in 1995 than in 1965. So how many more? That would be, in order to figure that one out, we want to subtract. You know, how many more cookies did you eat than, Susie? Subtract, right? Okay, so in 1995, in 1965. So we can see there was more in 95, 1.8 times 10 to the 11th minus 7.2 times 10 to the 10th. Okay, so before we can subtract these, we need to make the exponents the same. So how could we make this exponent into 11? Well, what I like to do is I like to think, how many zeros does this have right now? Right now, this would have 9 zeros because times 10 to the 10th means move the decimal place 10 times. But the first time is going to move it after the 2 and then 9 more times. So how can we rewrite it as times 10 to the 11th and still have 9 zeros? Well, if we're going to move it 11 times, then we are going to want it to be up there. And then moving it 11 times, you go 1, 2, and then 9 more times, 9 zeros. So you got to do that zero analysis and figure out, how many times you're going to move it. But then once you do that, all we got to do is subtract these numbers and then just make it times 10 to the 11th. So I would do that. And so I'm just going to borrow there. We get 8, we get 0, and we get 1.08 times 10 to the 11th. Let's see if I got it. All right. 1.08 times 10 to the 11th. I think I'm right. Got it. All right. That's great. So this one, you see we have a negative exponent. Remember those? Okay. So this time our negative exponents are not a fraction, but that means we're moving the exponent to the left. That would mean 1, 2, 3, 4, 5. So we'd have 1. Maybe you're saying, no, I don't know, but now you know. Okay, so this number is 0.000049. That's what I wrote there. And so if we add, so you could do one of two things. We can now add our standard forms together, or we could convert this into scientific notation. But since I've already written the number, might as well just use that. And then we're going to add 1, 2, 3 zeros. Oh, so easy. So then that's just 549 with 3 zeros. Okay. So you can just choose the most efficient way. And then if you're wrong, maybe it wasn't the most efficient way. Oh, I was right, but I just didn't write it in scientific notation like they told me to. But this is the right answer. So 0.000549 the right answer, but then I forgot we gotta convert it back into scientific notation. So we're gonna go 1, 2, 3, 4, 4 moves. So this would be 5.49 times 10 to the negative 4. So at this point, if you're feeling overwhelmed with all these different scientific notations, you can go to accelerated 2. I mean, you can stay in our class. I'm just saying, you're gonna need to do some different practice, and then go to unit 6, and you can do these things one at a time instead of, my rapid pace here. All right, so just whatever type of problem, or all of them, you can do that, or we can even do that in class. But okay, so let's see, Liam's math. So you're gonna just convert that number to scientific notation, and this one, convert that to scientific notation and approximate. And then here we want to divide the two numbers. When you divide the two numbers, what do you do with the exponents? You subtract them. You remember that? So I will let you give that one a try. Skip it for now. All right, this one, convert that to scientific notation and subtract. See if we can do that one based on the addition one that I did. All right, maybe I'll do this one for you, the word problems. No one likes the word problems. Okay, so with the word problems, we always got to figure out, are we adding, subtracting, multiplying, or dividing, right? So how many times would the annual flow of the Mississippi River fit in the Atlantic Ocean? So that is division. How many times would something fit into something else? We're dividing. Okay, so we have our Atlantic Ocean, 3.1 times 10 to the 17, and we have our Mississippi River, and that's 6.3 times 10 to the 11th. So like I said, we are dividing. So now I'm going to show you the division. So then we will subtract the exponents. So 17 minus 11 is 6. It's going to be 10 to the 6. And then we divide these terms. What is 3.1 divided by 6.3? Got my old handy dandy calculator. 3.1 divided by 6.3. And I got 0.4920 and a bunch of numbers. Okay, so it's about 0.492. So we need to divide those two numbers to get 0.0492. And again, we need to figure out how many zeros would this have, because right now it's not in scientific notation. And I'm not going to get another question wrong by not writing my final answer. Scientific notation. That would be one number in front of the decimal, 4.92 times 10 to the what? Well, let's see. This number has 6 decimal moves, would make 3 zeros. So if I've already moved it 1 back and I need 3 zeros, I'm only going to need 2 decimal moves, and then to get 3 zeros would be 3 more moves. So that would be 5 total decimal moves. Okay. I completely anticipate having to re-explain this in class, because this is tricky. But I want to give you time and a chance to practice it first. All right, so that's enough of scientific notation. Now it's on to the algebra. Are you ready? Let's clear this out. Okay, so now what we're going to do, we are going to solve equations with parentheses. We are going to do number of solutions. We're going to do the challenge. We're going to even do the unknown coefficients. And yes, give me your inequalities. So you just might want to, pause this video at times if it gets too long. But I'm going to keep going. All right, so we know about parentheses. I know you guys know that. So let's just distribute and then rewrite this. 6s minus 4 equals 16 plus 8 times 1/4 is 8 over 4, which is 2. So I'm going to write 2s. Put my draw a line. Put my variables on the left and the numbers on the right. Combine like terms. And now I'll be out of sight. Hey. Okay, divide both sides by 4. S equals 5. Prove it to you. Look, that. Okay, and so, just be careful with your negatives and you should be fine on that one. Now let's talk about number of solutions. Not all equations have the same number of solutions. I'm not saying that has no solution. But this one, what you want to do first is look at the coefficients of x. So that coefficient is -4. And after we distribute, that would be -6. So write this down. If the coefficients are different, there is exactly one solution. You don't even need to solve it any further. But here, look at this. This one, we would get, after distributing, we'd get -17y minus, I think 34 or something like that. And so, and then equals -17y plus 64. This time the coefficients are the same. So that means there's not one solution. Because if you put your variables on your left, you get 0. This would become +17 and they would cancel. And so now we look at the constant terms. Okay, write that down. If coefficients same, look at constant terms. If the constant terms are different, there's no solution. If the constant terms were the same, you can see there would be infinite solutions. A process of elimination. Okay, so it's one of those 3. And I can go right on to the challenge. We're going to use that same logic. Look right here, we got same coefficients. So now we look at the constants and they're different, no solution. Look at the coefficients, they're the same, and the constants are the same, infinite solutions. Look at the coefficients, they're the same, and the constants are different, no solutions. So, so your neighbor, your friend might solve the problem to figure it out, but you can see, you don't need to do that. coefficients are the same and the constants are different, almost the same, but they're opposites. So there is no solution. Which have no solutions so far? A, C, and D. Is there an E? There's no E. The answer is A, C, D. All right. And wasn't that fun? What is this number? This is going faster than I thought, which is nice. All right, so we've done, solving equations, number of solutions, scientific notation. And now, linear equations with unknown coefficients. So, sometimes we're going to solve for a variable. This is very important. So what we want to do, if we're solving for the variable, is get it on its own side and then get it all by itself. So we want to solve for x. First, we're going to distribute and clean up this equation. So then it'd be negative 3d plus dx equals kx plus 9. So then we're going to get our variables, the variable we want to solve for on its own side, like all the terms with that variable on the left. So dx is a term with an x in it. That's going to stay on the left. But kx here, that has to move. So that's going to become negative kx. And the negative 3d, that doesn't have an x, so that has to move. That's going to become positive 3d on the other side. Bring down the 9. So now we have the x terms on their own side. Now we're going to do something very special. We are going to factor out x. Whatever variable you want to solve for, once you got all the terms with that, on their own side, then you're going to factor it out. That is just, another way of saying factor is to undistribute. Pretty cool, huh? So then this would be x times the quantity d minus k equals 3d plus 9. Just rewrite that. And then the last step is to divide and get x all by itself. Divide. I know. You've never divided by d minus k before. It feels very uncomfortable, most likely. But it can be done. I just did it. So the answer is 3d plus 9 over d minus k. The answer is not a number. The answer is a crazy expression. But it is the answer. Nonetheless, 3d plus 9 over d minus k. Unless it's not the answer, let's find out. It's the answer. All right. So go for it. Try that. And the last thing I shall show you tonight for me, is a multi-step linear inequality. Don't be scared. It's just the same as an equation with one caveat. And let's write that down. The inequality caveat. If we divide or multiply both sides of the inequality by a negative number, the inequality sign flips. All right? Don't you ever forget that. Otherwise, your answer will not be correct. So let's see if that happens in this case. I hope so. But actually, I'm seeing it's not going to happen. So this will be an example where you see it's just exactly the same as an equation. The caveat does not apply because we won't be dividing by a negative in this case. Whew, I just thought to myself, I hope I'm recording because I don't want to do all this again, but I am recording. Okay, variables on the left, 12t plus 5t And then numbers on the right, bring down the 36 already on the right. And then this -2 is going to the right. It's going to become positive. So now I got 38 over there. And 12 and 5 is 17. All right, so, oh no, the 36 and 2, that's a bummer. Okay, so then it's not going to be a whole number. It's going to be t is greater than 38 over 17. And reduce any fractions. That's a reduced fraction, I believe. 38. So we're going to write it like t is less than 38 over 17. Unless I made a mistake. No mistake. All right, let's see if we can do one more. Oh, wow. All right, well, hey, just know that if you get to one where you got to flip the sign, you can make sure you post it in the organizer. But look at that. I did all of it. So now you try all of it and look ahead a little bit, see what we're going to be doing in the next unit. And then the unit after that is also updated. And that's where I stopped for tonight. But 13 weeks of content, that should be enough to keep you going. All right, I will see you in class with your organizer posts.